Okay, so farmer Susie grows turnips in ways the turnips are normally distributed with a mean of 122, standard deviation 14.7. So I'm going to introduce the random variable s of Susie. It's normal with a 122 and a 14.7 squared as a variance. And so if I want to find the percentage that the turnips weigh between 110 and 130, I'm simply going to find the probability that 110 to 130 is what I'm looking to find. If I go to my calculator, I'm going to go to my distributions, normal CDF, and I'm going to go from 110 to 130. My mean is 122, and the standard deviation is 14.7, and I can see that the probability, if I round that to three significant figures, is going to be 0.500. So half of the turnips weigh between that scenario. And so now if I have 100 turnips, I want to take it to market. Find the expected number weighing more than 130. Well, if I need to find the probability of Susie's being more than 130 grams. So again, I go to my calculator. I'm going to do the normal CDF, but this time my lower bound is going to be 130, and my upper bound is going to be a big number. And now I'm going to find that probability, which is 0.2931. If I want to find the expected value, it's going to be 100 times 0.2931, which is 29.3 turnips. So I should expect, Sally should find 23 turnips of the 100 that are more than 130 grams. Number 3 then says find the probability that at least 30 of the 100 turnips weighs this. Well, we're already getting into the binomial scenario here, because I know that success is either they're over 130 or not. Each turnip is independent of the other, and we have 100 trials. So I'm going to introduce y, which is going to be my binomial of 100, and my probability of success, meaning over 130 grams, is that. And so I want to find the probability that y is at least 30, so it means bigger than or equal to 30. Now my calculator doesn't do that directly, so I'm going to go 1 minus the probability of y being less than or equal to 29. I want to include 29 because I do not want to include 30. And so now I can simply go to my calculator, 1 minus the probability of binomial CDF. I have 100 trials. My probability is 2931. My x value is 29. And so I get 0.477 as the probability that at least 30 will weigh over 130 grams. Okay, so now moving along now to let me pull this down here to the next scenario here. Farmer Ray now, he has turnips that are normally distributed. So Ray has normally distributed where the mean is 144, but I do not know the standard deviation. But I do know that he only takes turnips that are 130 grams. And he has found that 1 in 15 is 130 grams. So what that means is the probability that Rays are less than 130 is equal to 1 over 15. Or I could also say the probability that Rays is bigger than 130 is equal to 14 out of 15. Either one is saying the same thing. And so I need to find the standard deviation. Well, if I take this scenario here, if I go to my calculator, if I graph it, and if I look what I've put into my, I'm using this scenario here, so I'm less than 130, up to 144 at my standard deviation of x. My window, well, my x value is standard deviations, and I can tell that Sally's standard deviation was 14.7, so it's going to be around this range of 0 to 25, I'm guessing. and the probability is the y value. So if I graph this, I can see that they intersect, and so I'm going to trace it and find the intersection. And so the standard deviation is 9.329. Oh my goodness, let me try that again. 9.33, just 3 significant figures. 9.33 is the standard deviation. So now it says Ray has 200 turnips to take to market. Find the expected number that weighs more than this. Well, I know that for Ray, he wants to find the probability of being 150, given that I know that Ray only takes ones that are over 130. Over 130. Well, that probability, if I find this probability, then I can multiply by 200 to find the expected number. So I know by conditional probability, this is the probability that Ray is over 150 and that Ray is over 130 over the probability of Ray being over 130. If we think about what this top one means, being over 150 and being over 130 just means simply the probability of being over 150 over the probability that Ray is over 130. Well, I know the bottom of my fraction here, over 150, is 14 out of 15. The top probability over 150, well, now I can go to my normal CDF. I'm going to go from 150, let me try that again. I'm going to go normal CDF. I'm going to go from 150 to some big number. My mean is 144. My standard deviation I calculated to be 1933. And so this probability is 0.26008. And if I divide that, I end up with 0.279. And to find the expected value, I'm going to go 200 times 0.279, and that will be 55.7.